a few different ways that we can figure out if ratios are proportional or not. Okay? I'm going to show you guys several different ways to figure that out. Okay, so here's our first method into figuring out if ratios are proportional or not. Okay? So here's our first test. Write this down. Method 1. Here's our first way to decide if ratios are proportional. We can write the ratios in simplest form. Yeah. We can write the ratios in simplest form. Now someone remind me what writing a ratio in simplest form would mean. Jacob?
Dividing them until they can't be divided.
Okay, dividing them so they can't be divided, or so that they can only be divided by 1, right? So here we have 10 over 24, and we're going to see if it's proportional to 15 over 36. Okay? So we're going to take 10 over 24 first, and write it in simplest form. So when I'm writing something in simplest form, what am I doing? I have to divide. And what do I have to divide by for 10 over 24?
2 over 2.
Okay, we can start with 2. Here we go. Divide by 2 on the top, divide by 2 on the bottom. 10 divided by 2 is
5.
5, and 24 divided by 2 is 12. And then we'll go ahead and take 15 over 36, and we'll put that in simplest form. So what's a factor that goes into 15 and 36? 3. So 15 divided by 3 is
5.
and 36 divided by 3 is 12. Okay. So are those proportional? Yes. That's one way that we can do it. If two numbers can be divided by the same number, means they can be written in a simpler form. If we get them both down to simplest form, we can check if they're proportional. Yes.
Do we write down that example?
Yeah. Any questions on method 1? This should be a review for you, right? Okay. So, is 10 over 24 proportional to 15 over 36?
Yes.
Yes, and the reason that it is because of the way that we got it down to the simplest form. Questions? Okay, I want you to use method 1 to decide if 10 over 12 and 40 over 56 form a proportion. Okay? That's another way of asking if they are proportional. Do 10 over 12 and 40 over 56 form a proportion? Alright, so I have a volunteer to come write one of these in simplest form, and then Donovan will pass it off to someone else to write the other one in simplest form. Anyone else? So did you guys get 10 over 12 is 5/6? Alright, let's do 40 over 56. Get your notes out, Riley. down on the bottom, can you go ahead and write our two simplest fractions so you can see it? Okay, so do these form a proportion? Why not? You can tell me why. Yes?
Because the denominator is, on 5 7 is bigger, well, 1 bigger than.
Yeah, because our denominators are different, right? Denominators would have to be the same. Our whole fractions would have to be the same if they formed a proportion. Any questions? Ready? Alright, let's do this one. Do 42 over 56 and 56 over 64 form a proportion. Question or answer, Greg?
Question.
Okay.
Well, on 42 divided by 56, I divided it by 7 and 6/8 is simplest form. So do we have to do it again?
One more time.
Wait, for 42 over 56,
Uh-huh.
I divided by 7 and got 6 over 8, but do I have to simplify it?
All the way. Simplest form of mean goes all the way. Okay? So where the only factor that they have in common is 1. Do I have 2 new volunteers to come do one of these for us? Crystal's going to do one, and then she'll pass it off to someone else to do the other one. You can write it underneath. There you go. Okay, what do you guys think? Do these form a proportion? No, because we got 3/4 and, you want to write no for us? We got 3/4 and 7/8. Are those the same fraction?
No.
No. Alright. Any questions on using the first method, getting them into simplest form? No questions on that? Okay, let's move on to our next method. Here's our next one. Using cross products. Cross products. Remember, this is two products found by multiplying the denominator of each ratio by the numerator of the other ratio. And we talked about this when we were doing ratios and finding whether they were equivalent or not. So how to test if the ratios form a proportion, the second method is to use cross products. So write down the second method to use cross products.
All of it? All of it?
If you want to write this down, you can. We already talked about what cross products means. But you do need to write down that the method is using cross products. Okay. So remember, we are going to make a bubble X. Right? And we're going to multiply one numerator by the other ratio's denominator, and then that first denominator by the other ratio's numerator. Okay? So we'll go ahead and put our equal signs out to the side of the second ratio, and we'll go ahead and multiply. 8 times 6 equals 48. And 3 times 16, 48. So if these two numbers equal each other, then the ratios form a proportion. Does that make sense? So if the two numbers equal each other, then they form a proportion. What do you think would happen if they don't equal each other? Grant?
Would equal or no? They wouldn't be,
What's that word?
proportion.
Yes, they would not be in proportion if they're not equal. Okay? You guys ready to try this? Question?
In our answer column, are we just gonna write yes or no?
If they ask you, do these form a proportion or not, you can put yes or no. Yes, they form a proportion, or no, they don't. Okay? Alright, let's try this one. Question?
Can we use cross products on these?
You can use cross products on every single one of them if you want. Okay? Simplest form sometimes doesn't work because sometimes there are already maybe one's in simplest form and the other one's not. So sometimes that doesn't work. Cross products you can use all the time. Okay, 9 times 4, Donovan, is? And 6 times 6, Elias? 36. So, do these form a proportion?
Yeah.
Yes. Okay. Now, if we have the really big numbers, like the ones we were doing before, 42 over 56 and 56 over 64, are those ones that we're going to want to use this method with?
No.
Probably not, right? How many of you want to sit there and do 42 times 56 on every single problem? Not me. Okay. So sometimes you're going to find a method that you'll feel comfortable with. Other times it's going to be one that you don't really want to use because you don't want to multiply big numbers. Okay? Why don't you guys work on this one? 4/8 and 5/9. Do they form a proportion? Let's have lunch with them. Did you get in trouble? Well, just make sure at lunch you go to front office. Or maybe your lunch is in front office. Do you usually bring lunch? Just go there. I don't want you to miss it. Alright, anyone want to come do this one for me? Riley? Is that what you guys got? No? So how do we know these do not form a proportion? Lauren? Yeah, these answers are not equal. If these answers are not equal, then they don't form a proportion. You guys with me? Any questions? Alright, last one using cross products. 4/10 and 6/15. 4/10. Do I have a new volunteer? All my same ones? Sato? Is this what you guys got? Alright, 60 equals 60, so these do form a proportion. Any questions on this? Any questions on the first method? Writing them in simplest form? Could we write these ones in simplest form and use that method if we wanted to? Sure. Can we use cross products? Good, I'm glad you think that. Okay. So no questions on this? Okay, we are going to do a guided problem solving. This is the back of your homework page. Okay, so, we're actually gonna work on this together, and it's gonna be part of our notes, not part of our notes. Guided problem solving is one question. Just guides you through it, alright? Okay, so let's go ahead and read this. Can you guys read it in the back? Kind of, not really? Alright, here we go. A certain shade of green paint requires 4 parts blue to 5 parts yellow. If you can do them in your notes or you can do them on a homework page, it doesn't matter to me. If you mix 16 quarts of blue paint with 25 quarts of yellow paint, will you get the desired shade of green? Explain. Has anyone ever done something like this where it calls for one part of something and another part of something else? Do you have an example?
Sometimes when I'm coloring, dyeing, frosting.
Yep. Okay, dye frosting. How many of you have ever made those frozen juice concentrate deals where you pour it into the bucket and then you add water? How many of you have ever done that? Okay, so usually it's the concentrate, the fruit concentrate, 1 part concentrate, and then how many things of water? 2 or 3, right, depending on or 4. Yeah, I do 4 because I don't like strong juice. But you decide how many parts of what. So 1 part juice to 3 parts water, or 1 part juice to 4 parts water, right? And that helps us if we wanted to, let's say, put 3, let's say we're having a party, and we wanted to put 3 of the juice concentrates in there, then we would have to figure out how many parts of water we would need, right? Thank you, Erica. Alright, so let's go ahead and look at this problem. They're doing 4 parts of blue to 5 parts yellow. You guys know blue and green, or blue and yellow make purple? Yeah, right.
Green?
Green.
Blue and yellow?
Alright, so circle information that you need. Can someone come up and circle or underline, because it's kind of small, underline some information that I might need in this problem. And you guys on your paper, I want you to write down the important things that we'll need. Ready, set, go. Write down the important things that you'll need. Alright, so she circled the 4 parts blue, the 5 parts yellow, and then she circled the 16 quarts blue and the 25 quarts of yellow. Okay, Lauren?
Their homework, are we gonna read it there? Are we gonna be able to get out of our binder before we leave?
Okay, so we circled the information that we needed. What are we being asked to do here? What is it that they're asking us for this problem? Say again? Okay. Will we get the desired amount of green? Well, if we mix any sort of blue and yellow, are we going to get green? Yeah. But we need to decide, are we going to get the right shade of green? Okay.
Well, what kind of thing are we asking for?
One more time.
Wow, why are we gonna ask them like what kind of thing of green are we?
So this shade of green requires 4 parts blue to 5 parts yellow, and that's the desired shade. So maybe you looked it up online and they said if you want this shade of green, make sure you do 4 parts blue to 5 parts yellow. And you bought quarts of paint. You bought 16 quarts of the blue paint and you bought 25 quarts of the yellow paint. You want to decide whether this is going to give you the right amount of green. Okay? The right shade of green. Okay? Will a ratio help you solve this problem? What do you guys think? Will a ratio help us solve this problem? Riley, why do you think a ratio would help us?
Because then we could put in like something small.
Okay, we can put it in simplest form. So I'm going to put yes here, you guys can put whatever you want for your explanation. But I think we all agree that ratios would help us with this problem.
Wait, are we just doing evens or just?
This is the back page. We're gonna do events on. Okay, so what is the ratio? Here's where we start working on this problem. What is the ratio of blue parts to yellow parts? Someone tell me what it is.
4 to 5.
What was the ratio that they gave us? Jacob?
4 to 5.
4 to 5. And I'm just gonna go ahead and put a little symbol here so I know which one's blue and which one's yellow. So 4 parts blue and 5 parts yellow. That'll just keep me organized. Okay. And then looking at the quartz that we bought, what is the ratio of blue to yellow?
16 to 25.
16 to 25. And again, I'm going to put my little... Now, if I wrote down 4 to 5 on one ratio and then I wrote 25 over 16 to the other, is that going to... Am I going to be able to set up proportions for that? If I do blue to yellow on one proportion, then yellow to blue on the next proportion? What do you guys think? If you set up a proportion where you're comparing two ratios, you have to make sure that the same colors or whatever they're talking about are across from each other. So if we set up this ratio, we have to make sure that the blue is across from the blue and the yellow is across from the yellow. Does that make sense? Okay.
What are we getting cross?
Let's look at number 6. Check to see if the cross products of the two ratios are equal. So we're going to set up the 4 to 5 and the 16 to 25 and use cross products to see if they're equal. Okay, Elias's row and over, you guys do the 4 times 25, and Crystal's row over, you guys do the 5 times 16. Dominic, what'd you get for your side? 100. And Edward, what'd you get for your side?
80.
Okay. Are the ratios the same?
Nope.
They sure aren't. Do you think we'll get the desired shade of green if we use this 16 quarts of blue to 25 quarts of yellow? Why not? Who can explain it to me? Why I won't get the desired shade? Donovan? They're not proportional. Okay, they are proportional. Can we use, oh no. This is like two separate, it's not forming a fraction.
Oh,
So it's just 80 and then 100. Good question. These are forming a fraction or its own ratio. These are two separate numbers, the 80 and 100, yes.
What happens if we decide to simplify the 16?
What would we get if we simplified the 16 over 25? Can we simplify it by anything? Is there something that goes into 16 that goes into 25 also, evenly? So, this is a good example of when we can't use simplest form, right? Because 16 and 25 don't have a common factor. Does that make sense? So, cross products is the only one that works here. Any questions? You guys feel pretty comfortable with this? We already answered that. I said, how do we know that the ratios aren't the same? And you guys told me because these numbers aren't equal. Okay. Any questions? Ready to start homework? Okay, do you think we need a work page tonight? What do you think? Yes, you do. You can use method 1 or you can use method 2. Doesn't matter to me. As long as you understand whatever method you're using. Okay? So get out a work page. If your homework book or your homework page is in your binder, go ahead and grab that out now. And I'll come around and help you if you need it. I'll put it on the board.